All right, we are going to wrap up our discussion of chemical reactions now by talking about Le Chatelier's principle. Le Chatelier's principle is all about shifting equilibrium in a system. So, the first thing is we need to understand the definition of Le Chatelier's principle. Le Chatelier's principle, in summary, basically is a system at equilibrium that is stressed in some way will shift to relieve that stress. What I like to consider in this case is this analogy. So a hen lays eggs. What a hen wants to do is it wants to be sitting on eggs and doing its maternal thing. It wants to have eggs, it wants to have chicks. Well, what a farmer does is he profits from selling the eggs. So what he will do is he is going to take the eggs away. When he removes those eggs, now the chicken is stressed. The chicken is not it's not at equilibrium, if you want to think of it that way, right? It is not happy. It has been stressed. Well, what a chicken has the ability to do, though, is it can modify the situation by laying more eggs. So, I remove eggs, the chicken is stressed, the chicken lays more eggs. Okay? Now, this analogy applies very well to chemical reactions. The stressors that we consider are we can have concentration changes if you add or you take away molecules. So like take away eggs, that would be the stress, right? Take away molecules. Changes in temperature by heating or cooling, because temperature is a factor in the majority of chemical reactions. And changes in pressure. By increasing or decreasing volume, we can modify the pressure. Now, we'll begin by considering this equation. Carbon monoxide gas with hydrogen gas forms methane, CH4, and water. Adding molecules causes a shift away from the side that gained the molecules. So what I like to consider here is, let's say I'm going to add carbon monoxide. Okay? If I add carbon monoxide, what ends up is I have an imbalance. I have too much on this side. That is the stress. I have too much on the side that I added to. The system responds to this stress of too much on the left by shifting to the right and making more, so it makes products. Now, if I were to, instead of add molecules, if I were to remove molecules, okay, so instead of adding CO, if I were to, let's say, take away hydrogen gas, if I were to lose H2, the problem that I now have in my equilibrium system, right? I lost H2, so the problem is too little on the reactant side. I don't have enough. The system responds to that stress by shifting to the left, and it's going to make more reactants. So that's the general idea here. Wherever the change is, consider if I have too much on one side, it shifts away. If I have too little on one side, it shifts towards. Just consider it in those terms. Now temperature is a reactant for endothermic reactions. It's a product in exothermic. Okay, so endothermic on the left, exothermic, it'll be on the right. Considering this reaction again, notice that we've now added the enthalpy value. Our enthalpy is a negative value, so negative enthalpy tells us this is exothermic. It is going to give away heat. So if I consider it that way, I want to write for exothermic processes heat in as a product. So CH4 plus H2O plus heat. So when I've done this, I can now consider heat as though it's a concentration. If I were to add, whoa, that's a nice arrow. If I were to add temperature to this equilibrium, my stress is I now have too much product. Okay, so I'll have too much product. This is going to cause a left shift, and it is going to make more reactant. Okay, so that would be the result of increasing temperature for this system. If I instead were to decrease temperature, now I'm taking away product. So the problem would be too little product. And if my issue is too little product, that's going to cause a right shift, and we're going to make more of the product. Okay? So now consider volume changes. If I were to decrease the volume, so if the volume goes down, the pressure goes up because these molecules are closer together. So we're going to consider this reaction again. First off, this is the system at equilibrium, and I'm now going to decrease the volume, which is going to increase the pressure. What we see happening is the system will shift to reduce that pressure by reacting to form fewer molecules. All we have to do is check the balanced equation and see which side has the largest total number in the coefficients. So here I have 1 and 3 is a total of 4. Here I have 1 and 1 for a total of 2. If my problem is too much pressure, I can get less pressure by shifting to the side with fewer moles. So that'll be a right shift, which is what we see happening here. We have the CH4 here. At first, I only have one CH4. I have 1, 2, 3, 4, 5, 6 of the carbon monoxides. So I've got 6 plus 1, and I have, let's see, so that's the hydrogen. I have CH4. I have 1 water plus 1 H2O here, and then it looks like I have 2 carbon monoxides, and that gives me a total of 6, 7, 8, 9, 10 total molecules. Well, if I have little space, this is going to cause a shift. Now I only have 3 hydrogens. I will have 2 waters. I will have 1 carbon monoxide, and I will have 2 CH4s. And if I add these now, I see 3, 4, 5, 6, 7, 8 total molecules. I have more products, I have less reactants, and that is the end result. So I'm going to go ahead and pause this, let you get these practice problems done. Now I'll assume you've worked out your practice problems, and let's go through these. So restate Le Chatelier's principle. So Le Chatelier's principle says that a system at equilibrium that becomes stressed So a system at equilibrium that becomes stressed will change to reduce that stress. Okay, so that is a restatement of Le Chatelier's principle. Consider the equation N2 plus O2 makes 2 NO gas with a delta H of plus 180 kilojoules. Adding N2 would cause more blank to be produced. So more N2, we want to think more N2 would be too much reactant. Too much reactant results in making more product. So adding N2 makes more nitrogen monoxide gas. Removing oxygen would cause more blank to be produced. So if I remove oxygen, the issue is now I have too little reactants. So I have too little reactants, which means I need to have a left shift. I need to make more reactants. So you could write in reactants, or it's going to form more N2 and more O2. Heating the reaction vessel would cause a blank shift. So now we have to consider heat. The delta H is positive, so this is an endothermic reaction. It absorbs heat. So we would write heat on the left. It's heat plus N2 plus O2 makes 2NO. So causing this heating the reaction vessel, it's adding reactants. So the problem would be too much reactant again. And that would cause a right shift, it will form more product. Decreasing the volume of the container results in blank. So now decreasing volume, we've got to think of it this way. Less volume means more pressure. This is my stress. I have too much pressure. The way that I alleviate the pressure is by shifting to make fewer moles. Here I have 1 and 1 for 2 moles. Here I have 2 moles. So actually in this situation, there's no way for the equilibrium to decrease its own pressure because it has the same number of moles either way. So decreasing the volume of the container results in no change. Now consider N2 plus 3H2 shifts to make 2 NH3 with a delta H of negative 91.8 kilojoules. What change in temperature causes more NH3 to form? So we've got to consider this as an exothermic process, which means heat is a product, so that's plus heat. A change in temperature that would cause more NH3 to form. If I want more NH3, which means I want a right shift, the way that I can force that to happen is by taking away product would cause more product to form. So I will decrease my temperature, and that forces the right shift. What volume change causes more NH3 to form? So now I want to know what would cause more NH3 to form. Again, I want a right shift. What volume change would cause that? So a right shift, if I take a look here, I see 1 and 3 is 4 moles of reactant to 2 moles of product. So I'm going to need to form fewer moles of product. To form fewer moles of product, I need to add stress. I have to add pressure. And the way that I add pressure is a decrease of volume. So I will decrease the volume to increase the pressure to cause a right shift.